Hi Algebra 2 students. This video is on solving exponential equations, and it's also going to be an introduction to logarithms. So we were looking at logarithms in class today, and then solving exponential equations is what we were doing earlier this week. So I'm going to give you some examples of this, and then we'll kind of formalize what we were doing in class into notes. So to start, I'm going to say part A of our notes is on solving exponential equations. And remember, the big idea here, I'm going to kind of say big idea, is that if we have both sides of our equation with the same base, so if both sides of our equation has the same base number, then we can set their exponents equal to each other. And then it becomes an easier equation to solve. So we'll set the exponents equal and solve for the missing variable. So we're going to look at some examples now. The first example here is going to be 81 to the 3x minus 3 is equal to 27 to the negative 3x. So the idea is I don't have the same bases, but I could get the same bases because I know that 27 is 3 to the third power and 81 is 3 to, oops, I meant to write to the fourth power over there. So then if I rewrite those bases and then just bring down the exponent that was there, now I have the same bases, and this allows me to then set one exponent equal to the other exponent. Now the important thing to remember here is you need to distribute that 4 or 3 into the other exponent part of the equation. So it'll become 4 times 3x minus 3 is equal to 3 times negative 3x. Now from here, you should know what to do from here, right? This becomes an equation like you did in Algebra 1. So I distribute the 4, I multiply the 3 and the negative 3 to get negative 9x. Now I'm going to add 9x over and add 12 to the other side. So I get 21x is equal to 12. And then I'll divide both sides by 21. And I get x is equal to 12 over 21. Okay, so that was a pretty simple one. Now let's look at something a little bit more challenging in our next example. So we have 1 over 64 to the x minus 2 power is greater than or equal to 16 to the 3x plus 1. So now we have a fraction, right? So I need to try to get these to have the same base. So I'm thinking, I know 16 is 4 squared. So I'm thinking about 4 already, and then I know that 64 is 4 to the third. But since that 64 is in the denominator, I need to make that a negative 3. And now I'm going to bring down my other exponents. And now I can see what I'm going to set equal to each other. This negative 3 times x minus 2 and 2 times 3x plus 1. So I get negative 3, x minus 2 is greater than or equal to 2 times 3x plus 1. From there I can distribute, so I get negative 3x plus 6 is greater than or equal to 6x plus 2. I'm going to subtract the 6 over and subtract this 6x to the other side. So I get negative 9x is greater than or equal to negative 4. And then at this point, to get x by itself, I would divide by negative 9. Now, be careful, this is an inequality, right? So in inequalities, when you divide by a negative, you flip your sign. So it was a greater than sign, now it's a less than sign. So I have x is less than or equal to 4/9. All right, so now let's slide the paper up so we can do a few more examples here. So for example 3, Now we're going to look at an example that this is actually a homework problem, but a lot of people were stumped on it and we didn't have a chance to talk about it, so I wanted to put it in a video. So we have 7 over 343 to the x minus 3 is greater than or equal to 1 over 49 to the 2x plus 1. So to start, you may not be sure how to convert 7 over 343 into some base raised to a power, but you can start by breaking down the 343 and the 49, and then I think you'll have an idea of what to do next. So from here, I'm going to rewrite the left-hand side as, I'm going to think about that 7 is still a 7, but I'm going to think about it as to the first power. And then 343, I know, is 7 to the third power. So now I've rewritten my base as 7 to the first over 7 to the third to the x minus 3. Then I'm saying that's greater than or equal to, 49 is 7 squared, but since it was in a fraction, I'm making that a negative 2 to bring it up. And I carried down my exponent. So now, if you notice, I have 7 to the first over 7 to the third. I can use my exponent rules here. So I know I would subtract my exponents, 1 minus 3, and I'd get 7 to the negative 2. Now I have 7 to the negative 2 to the x minus 3 is greater than or equal to 7 to the negative 2 to the 2x plus 1. And now I can finally have 7 and 7, so I can set my exponents equal to each other. So from here I have negative 2 times x minus 3 is greater than or equal to negative 2 times 2x plus 1. Now I'm going to distribute and solve like a normal algebra 1 equation. So I distributed. Now I'm going to get my variables on one side and my numbers on the other side. So I get 8 is greater than or equal to negative 2x. And then I would divide both sides by negative 2. Remember, your sign would flip at that point. So I get negative 4 is less than or equal to x. And one final example in this section of our notes. I'm going to have, this one is going to look really crazy, but I'm going to show you how it just becomes like what we've been doing. So we have 1/6 to the 3x plus 2 times 216 to the 3x is equal to 1 over 216. Okay, so to start, I know I have two different bases to powers on one side, and we haven't really seen something like that, but I'm going to show you what to do. So step 1 would be get all your bases to be the same. So I know that 216 is 6 to the third. So I'm going to try to get all of these to be a base of 6. So for the 1/6, I'm going to replace it with a 6 to the negative 1. For the 216, I'm replacing it with a 6 to the third. And on the other side, I'd have to replace 1 over 216 with a 6 to the negative third. And now let me just fill in the blanks of what I left out. So I have to bring down my exponents. So it's 6 to the negative 1 to the 3x plus 2 times 6 to the third to the 3x is equal to, and then there was no exponent over here, so I'm just going to leave it. All right, so what should we do next here? Let me zoom in on this problem. So I know I need to think about following my exponent rules now on the left-hand side to get this to be just kind of one thing. And the key is going to be to remember that when you have the same bases being multiplied, you'll add the exponents. So I'm still going to be setting all my exponents equal, but I need to put an addition sign between this one plus this one. So what does that look like? It looks like negative 1 times 3x plus 2 plus 3 times 3x is equal to negative 3. Okay, so to recap, we had bases that were the same being multiplied, so I added the exponents when I set each exponent equal to the other side. Now I'm going to distribute and combine like terms. And now I'm solving for my variable, adding 2 over. I get 6x is equal to negative 1. Dividing by 6, I get x is equal to negative 1/6. So now we're going to move on to the second part of the notes. So I'm going to call this part B, which is our introduction to logarithms. Okay, so we had this notation, log base b of x is equal to L. And by definition, we say this statement is basically equivalent to, actually, to saying b raised to the L power is equal to x. And in math, we say one implies the other, or we say if and only if. Okay, so we kind of have this equality statement, and the other way we kind of symbolize this is with this like double-sided arrow. So if I know this, if this is true, then this is true, and it works both ways. If this is true, then we know this. Okay, and this is kind of basically what we were looking at today in class. So then the other thing I'm going to add underneath is we'll say when b is greater than 0, because we saw that b can't be 0, because 0 to any power is still 0, and that b can't be negative because when it was negative, sometimes it worked and sometimes it didn't, depending on if you had an odd or even power. So we're just going to exclude negatives, exclude 0, and then the other thing to exclude is that we don't want b to equal 1. And the very last thing I'm going to say is we actually want to also say that our x value is positive, not negative. Because if our base here is always positive, then there's no way that this x is going to be negative. You can think about it over here, it might make more sense. Like if we're always raising a positive number to some power, then we're multiplying only by positives, so this is just going to always be positive. And that's why we say x is greater than 0. Okay, so that's kind of like our basic definition, and now I'm going to just run through a couple of different types of examples. So for this section, I'll have example 1, and it's going to be multi-parts, which is just rewriting logarithms. So we can think about this as there is a logarithmic form, and there's also an exponential form. Oops, exponential. And then we can kind of move back and forth between the two forms, right? Logarithmic form looks like this. Exponential form looks like this. So with our first example, if I start with a logarithmic form, let's say log base 2 of 8 is 3. So I know that to be true. Then my exponential form equivalent, kind of go over here, would mean 2 to the third power is equal to 8. Let's look at another one. So in this one, we'll do something a little bit, we had to think a little more. If we say log of the 1/4 is 4, if we think about that for a moment, so we're saying 1/4 to what power is 4, it would be -1. And then if I want to write that in exponential form, I would write 1/4 to the -1 power is 4. Now let's do two examples where we start with the exponential and go to the logarithmic. So suppose we start with 3 squared is equal to 9. Then going this way, I would write log base 3 of 9 is 2. I don't really need those parentheses, so it's okay not to have them. And then the next one, let's do 5 to the 0 is equal to 1. So we would have, call this example D, log base 5 of 1 is 0. So in the next type of example, so here we're just kind of like saying what is the equivalent, right? Oh, sorry, let me put in these arrows. So now in the next set of examples, we're actually going to evaluate logarithms, which is essentially what we were doing in class today, except we were calling it the what power function. Evaluating logarithms. So for our first example, log base 4 of 64. So I'm thinking, and if it helps you to write it, you can. 4 to some power is 64. Well, I know that 4 to the third power, 3 would work up there, is 64. So then my answer here would be 3. For the next one, log base 5 of 0.2. So I'm thinking 5 to some power is 0.2. Now, it might be helpful to write the 0.2 as a fraction. So I know that this is 2/10, right? 2/10 is the same as 1/5. So what I'm really wondering is 5 to what power is 1/5? In that case, that means I'm going to need negative exponents to flip this, right? Because 5 to the negative 1 would be 1 over 5. So that's cluing me into the fact negative 1 needs to be the number that goes there. So log base 5 of 0.2 is negative 1. So in C, let's do log base 1/5 of 125. So this one is one it's definitely gonna be helpful to think about the exponential form. So I'm wondering 1/5 raised to some unknown power is equal to 125. So because this is a fraction and this isn't, I know I'm going to need a negative exponent up here. And so I know I'm going to put that negative first, and then I'm thinking, okay, well, 5 to what power is 125? 3. So the 1/5 to the negative third would equal 125. And you can kind of, if you're not convinced, 1/5 to the negative 3, well, the negative means flip it, right? So that means that's equivalent to 5 to the third, which is 125. So that checks out. So my answer over here is going to be negative 3. Okay, let's do one more example, this final space on my paper. Let's do log of 36 is, so log base 36 of, let's do 1/6. So now I'm wondering 36 to some power is equal to 1/6. So my first thought is that I know that the square root of 36 is 6. So my first thought would be that this should be a 1/2. But then I would just get regular 6, not 1 over 6, right? So then I'm thinking, oh, well, in order to get the 1 over 6, I'd have to make that negative 1/2, right? Now, 36 to the negative 1/2 is the same thing as, you can think of it as 1 over 36 to the 1/2, and that 1/2 means square root. So if I square root top and bottom here, I get 1 over 6, and that checks out. So my answer that I'm writing over here is negative 1/2. Alright guys, so after you finish this, you should take a look at problem set in your workbooks on page 54 and 55. That's lesson 8 problem set numbers 1 through 12. Have a great 4-day weekend, everyone.